Okay, I'm just gonna write about the direction that I want to go in with my learning. It's just like an A4 sheet paper that I'm doing it. So let's want to do. I want to learn the top triangle neat code. That's one goal. Do a clone project full stack and comedy app and BJJ app. So those two will be my main projects in this category. Full stack is just like get a base level understanding of how to do a full stack app. With that, I'm avoiding all of the math for now because I'm in serious need of getting some job. I'm avoiding math for AI. I'm avoiding math for just like data analytics. I don't want to do that. I think a lot of my BJJ stuff could technically like move into that kind of direction, but for now, I want to open source contribution. I need to do that later. Okay. This is the goal for now. Hopefully, I can get the above done before the end of December and do some AWS stuff and start applying. Okay. I want to learn some PyTorch, just like a framework that I want to get good at. So PyTorch for personal projects and bro, should I do PyTorch at all? Should I do PyTorch at all? Should I keep it on the side? Again, okay, I'm just gonna write it down. Just gonna write it down. PyTorch, personal projects, comma, understanding to be continued. Okay. I think that's a solid foundation. Okay, let's do some projects.
Yep.
I mean,
So
and
the
data
longest
structure.
common prefix would be FL. Now the first two words start with flow, so that almost works, but it has to match all of the strings. So the longest consecutive matching of all of the letters is just the first two, which is FL. Okay, in this one, if you have dog and race car, okay, actually it doesn't even matter what car is over here. Clearly, there's no common prefix even amongst these two because one starts with a D, the other starts with an R. So they have to have all of those exact same letters starting from the very beginning. Okay, so let's deal with that same example here. And the idea is that you would want to kind of check for each of the strings in order. You'd want to make sure that all of their letters match. So you'd want to make sure that the first letters match. Okay, we have at least F. Okay, do their second letters match? Yes, they do. Okay, we have FL. Do their third letters match? This is an O, this is an O, and this is actually an I. Okay, so we have that problem there, and so we would just want to return FL. So more mathematically or computationally, what we're really doing is actually just keeping a common index I. So it's going to make more sense if I kind of stack them up like this. So now it's pretty easy actually. If you have an index I, which we would start at 0, well, we just need to make sure if they are all equal to each other. Now it's actually really easy to check if all of these things are the same here. You have your index, and if this is, string A, string B, and C. Technically, they'd be in a loop, and so it'd be something like, the strings at 0 or the strings at 1 and so on. But we'll just call this A, B, and C. Basically, what you would do to make sure that all of their letters at the index matched is to just compare them to A. Because if they're not matching A, well, then that means that one of them was different. Okay, so this strategy would mostly work. You would say, okay, we have I is good so far. You'd go over here. The L's are matching. It's good as well. But over here, you would hit a problem because this O matches, but this I does not match. Okay, you'd want to return kind of any of the strings because they're all kind of the same up until this point. So you just want to return any of the strings up until but not including I. That substring there. Now, that's pretty much the idea, but there is some interesting edge cases to deal with here. So if we kind of change it up here so that they are all looking like flow so far, so they're all flow. However, if we make it look like this is flower, this is flows, and we'll just leave this as flow. Well, this would kind of break our example here as is, because you'd make sure that the letters match at this index. Okay, they do. They match over here, they match here, they match here, except then when you try to check this one, well, then this one's in bounds, this one's in bounds, but this is kind of an out of bounds error. You'd be trying to access that string at something that didn't exist. So before we kind of do any of this index magic, you'd want to find out the minimum length of any of the strings. So we'd want the minimum length, and you could just kind of go through each of the words, get the length. This is a length of 6, this is a length of 5, this is a length of 4. Okay, you could find that pretty easily and find the min length is 4. That way, if you ever actually get kind of out of bounds there, if you know that the minimum length is 4, aka that the last valid index for the strings would be 3, it means we don't check and go out of bounds here. So if you actually get to that min length, because this would be 0, 1, 2, 3, and 4, if you actually get your index to that out of bounds, well, then you can just return early here. You can return any of the strings up until that point because they all are going to look the same there. Okay, we want to make sure we don't go out of bounds for any of the strings, so we'll get the minimum length of any of those strings. So we'll say min length is equal to, so far, the float of infinity, and we'll go through each of the strings. So for each s in the strings, if the length of s is less than our minimum length, okay, we found a new minimum, and so min length is going to equal the length of s. Then while I is less than our min length, we want to, for each of the strings again, we want to make sure that each of the strings at that index are all matching, aka we can actually just check if they're all equal to the first one. So if s at I is not equal to the first string at that index, well, that means that one of them had an issue. So we can actually just return s up until I, basically saying, okay, it was okay up until I, except now I hit a problem. So one of the strings at that index had a problem. This is actually exclusive, so this syntax automatically says all the stuff up until but not including I, meaning that even if there was a problem at the very beginning, if I is 0 and we had a problem with the first character, okay, we're actually not even going to include that, and we'll actually automatically return the empty string from that. Okay, if we get through all of the strings here, then there was no problem, so we can simply do I plus equals 1, and then from here, we do actually run into a couple of edge cases here, and I feel like it's just kind of best to show you as why they come up here. So this looks all okay so far, but when you go to submit this, one of the cases here we'll have is if you have the
Okay, this is not a bro. Why so hard to like find some decent ones? I know the whole point is to like to understand the question rather than to get it right every single time. But it's like, what is going on in here? Do they have ChatGPT in here? They don't. Oh my god. They don't have ChatGPT. I think that's like a missed opportunity. This line extracts the ith character from the first string in the list string. What? Example. Oh, I need to write something down. Oh my god. No. Let's go. Let's try to print this. Why not? Fuck you. I think it's gonna be the first. But why is that though? Will it even return anything? So it's the second index. Let's do -1. So that's a thing. How is that even a thing? Okay, that's a thing. I didn't know that. So we have what is n? N is the okay. Answer for I in range m. Why the length of this? I don't get it. Like, what if? Can I add a test case? No. Fuck no. Let's do another one. No. I mean, let's go here. Practice. It's 14, right? How can I search? Horizontal scanning. This is the method that I was thinking of, but they gaslighted me into thinking it doesn't exist. It does exist. Okay, wait. What? I surely didn't write this code. No way I wrote this code. Fuck no. Look at this, bro. This is like, what even is this code? Is this code readable? If the first, why zero, okay, 0 of I is not equal to minus 1 of I, return the 0 of I, if not return 0, string of 0, first index. Okay, let me see that again. So if length of, so all of these are like else block, comes under the else block. So if length of string is equal to 1, return strings is equal to 0. I don't understand the 0 thing. What does 0 mean? Okay, we are just sorting the, so the biggest, okay, I kind of get the intuition behind it. That's the first, that's vertical scanning. That is sorting. What does he do?
Conditional out here. So, okay, so we're iterating through every of strings, and we among all of these strings we want to return whatever is the longest common prefix. Now, what is a prefix? Well, it's just a portion of the string. So for example, this string flight, a prefix is just any portion of the string starting from the beginning. So f is a prefix, fl is a prefix, fli is a prefix, flight itself, the string itself, is a prefix. As long as it starts from the beginning and is continuous, then it's a prefix. And we want to return the longest common prefix among all of these strings. So, what's the intuitive way to tackle this problem? Well, look at the beginning, right? All three of these strings start with an f, right? So f is a common prefix among all of these strings. Let's look at the next character, l. L is the second character in all of the strings. So another prefix that's common among all the strings is fl. Now let's look at the third character. O is the third character in this string. O is the third character in this string, and I is the third character in this string. So unfortunately, flo is not common to all three of the strings. It's common to these two, but it's not common to this one. So fl is going to be the longest common prefix that we have, so that's what we can return. So the problem really is that simple, but there are a couple edge cases that can trip you up if you are a beginner. So we're going to be focusing on that, especially when we code it up. So basically, we are going to simultaneously iterate through all of the strings that were given.
If the length of string is equal to 1, return the string. Cool. If not, sort the string. And for I, okay, let's sort minimum, which is what? Minus 1, which is the less. Of course, it's. So we're iterating. Bro, you don't even have to do it. You could just like write len. Oh, sometimes it will be like the same one, but still. Oh, that's like extra memory. So whichever is the smallest, the first. So we're taking flow, flower, and flow. This one is 3 and this one is 5. So whichever is the smallest, we are iterating that many times. That makes sense. And so we just like iterating through that. And if the if the first one, I, isn't equal to the last one of the first thing, is not equal. If it's not equal, we're just returning the first two okay, 0 plus 1, whatever. Okay, no, yeah, makes sense. We are returning this. That makes sense actually. But this part over here, I think this could be completely skipped by just writing this in it. Just going here. What's wrong with that? I don't see anything wrong with this code at all. Yeah, exactly, yeah. Will it pass the test case though? I'll try to do this now. So the first condition being, if the length of the strings is equal to 1, if the length of the strings equal to 1, if it is, we're just going to return strings of 0, comma 1, or 0, comma. If it is 1, we're just going to return that. Else, we're going to have this block of code where strings is equal to sorted of strings. Yes, for I. So we're gonna iterate through the entire range of the lowest length of the entire thing. So it's gonna be the last one, last string. You're going here. So we're iterating through the entire, iterating how much ever the last string, which is going to be the lowest value. So you can kind of go, go on the first one, which will be the largest length, but we want to go to the last one. This will make sure we don't like do extra iterations. Helps with the concurrency. So if string of 0, so the first, we're comparing the first and the last because it will get arranged in a certain specific order so that the first and the last can be compared. If they're not equal, we can just return. We can just return null. If they're not equal, let's say the first is flower. Okay, let's take a look at in this example where this will get rearranged into, let's assume this is the perfect order, which it isn't. The perfect order would be something like something a little different. So we can use this. I, yeah. So if the first letter is not equal to the last element, it's gonna be, if it's not equal, we're just gonna return, we will just return strings of O, comma I. Because we wanna get the perfect thing. And for the else block, it's gonna be, so let's run this. Oh, we're just gonna run out of the loop, and it works. Pretty sure there should be like an edge case where, again, when the entire loops over, and we couldn't find something, we should return nothing. So that's gonna be, I mean, yeah, if every single thing is like the exact same thing, so flower, 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 we just need to like, I think we don't actually need it. Fuck you, bro. I'm looking down on people.
Trip you up if you are a beginner. So we're going to be focusing on this string. They both start, and that makes sense, right? Of every they're common. Or if you want to, overall, we're going to just, that said, we're these three characters, the arbitrary for loops that we're, but we, this condition is out of bounds, right? Then we're going to also, that is common among all the strings to our result. And then once we're done with all of that, we can go ahead.
I don't want to do this method, it's too much. too much. Too much to iterate over, too much to like just do. Need a little bit more simpler way to do it. The simpler, the better it is. Complexity is for morons. So this is called first and last comparison method, bro. It is not brute vertical, divide and conquer. Okay. Prefix is bound by string as mode. Here rename what? Let's search for this. Don't actually believe in that, so let's prefix by bounding string. Let's look into this. Oh, fuck's sake. Oh, calmly. I don't think it's gonna work. Let's look at this one. It's not even the thing that he's showing, so what is up with that?
Right? Then we're gonna also return, right? We're not even gonna on works with the entire long strings and works was please like and subscribe. Yes, it works. And
Bro, it works,
is
but
pretty
it's shit. It's pretty shit. Oh my god, bro, it's so shit. Solution. Give me that. This is the 100%. What is it called? That's the binary search. Vertical scanning, column by column vertical scanning, bro. Fuck it. Sherlock.
In this video, we'll go over LeetCode question number 14, longest common prefix. Given an array of strings, we have to
Bro, just copying the other guy. Copycat. Vertical scanning, so this is the one that he showed. It's the 100% one, I assume. So for, is it the 100% one? For I in range, length of string, what is going on? If okay, for I in range of length of so we're getting the first, let me get this straight, length of string O. So we're getting the first word, cool. And what is the length of it? Let's say it's 5. Doesn't really make sense. Okay. Flower, comma, flow. Okay. Let's say it's 5. For S in strings. So let's say we have 3 elements. Okay, 3 elements. If one is equal to length of S, what? So let's say it's 3. So it's going to iterate 3 times before it returns the. That makes sense. Or S of I. So the first element, flowers, is not equal to strings of first element, flower, first element and first. It's okay. So we're just using the first element to like compare. If it is equal, what? It's still Z. That will never be equal though. That will never be equal. If one of those is true, meaning we've reached the length of the string with the iteration, this makes sense. If we didn't, we're just going to return the first value. That's cool. But we're not even sorting it though. Should we need to sort it? Will it work? Let's try it on. I think this is the best answer, but kind of works. Let's see. It is difficult. Really, really difficult, but kind of makes sense in a weird way. I just need to use this thing, and I did remember double indexing and slicing is the name of the game for this. And yeah, I will try to recreate this. Let's try to do this. Double indexing, and I need to double index it, and slicing methods. So those are the 2 things that I need to do with this particular thing. How do I forget? Can I do strings is equal to sorted strings? Submit. So wait, what? So there's 2 for loops. I didn't even realize it. What the fuck? So there's 2 for loops. Oh my god. How come I'm not? Yeah, that makes sense. That makes sense. That makes sense. So two for loops. Valid parentheses. I just want to fuck people up. I need to use a hash set, if I remember correctly. And for I in strings, that doesn't seem right. That's one way to do it. And so if oh yeah, I need to do the hash set thing. Annoying. So this is 20. So yeah, I need to do this annoying hash set, which I'm just gonna copy the thing, bro. And I'm using a stack, an empty stack. So I think we're first appending stack.append. Append I, and we check if I plus 1 is retarded. Okay, let's just that happened, and we need to go to the next element somehow. So what are the test cases? So let's say this would be false, right? Again, it is a stack problem.
What is
What is going on? This is a bad question to like practice it. I'm going in random order, which I shouldn't do. Let's just no, I don't want to do this, bro. This one. Find the missing value. Find the missing and repeated value. Topics. Matrix. Oh my god. Okay, you're given a zeroth index 2D matrix grid, the size of n into n with values in the range. Okay, each integer appears exactly 1 except a, which appears twice, and b, which is missing. The task is to find the repeating and missing numbers of a and b, return the zeroth index array nums of size 2, where ans 0 equals to a and equals to b. What the hell, bro? Okay, let's time it. Reset. Okay, you're given a zero index 2D integer matrix, so it's a matrix grid of size n comma n. Okay, it's like a similar to like a chessboard type question, with values in range from range I to the n square. So that's going to be, okay. It's going to be like a 2D matrix with a lot of, it's a repeating, it's like a repeating thing. It's going to be a square matrix. Each integer appears exactly once except a, which appears twice, and b, which is missing. Your task is to find the repeating numbers a and b. So we can look at this. So 2 is repeating in this one. The number 2 is repeated, and 4 is missing. Okay, 9 is repeated, and 1, 2, 3, 4, 5 is missing. Okay. I think we can like write 2 different like functions for missing and repeated, but I feel like it could be like a much shorter code by me just writing it in a single modular function. So we find which element is missing. So I'm going to use a hash map to find which element could be missing. So this is going to be an empty hash set or a hash map. So if it's not found in the hash map, at the end it's going to return the number which is not found, or what does it say? It's going to return 0, I think. Return no 0th index integer of size where equals, okay. So what happens when there is no repeating? That would be like an invalid test case, because it's a square matrix, and if it doesn't, it should do it, because it's like turning a corner on a Rubik's cube, right? Like it's not possible. So for I in the grid, let's say, we need to iterate over every one of them. So let's be more specific with lists. For list, it's a keyword. With lists, let's just use I. No, I feel uncomfortable using it. So for I in grid, if I is found in hash maps, we could just, if it is found in hash map, no issue. If it's not found in hash maps, we need to append, hash map dot append At I, if it is found, in I just have to return.
I need
I need to
to
return.
which
So which comes first? I think the
duplicate
duplicate comes first, right?
So
So I need to return I, comma,
missing.
missing.
So
So
on top
on
of
top of
here,
here, we're gonna write the logic for the
missing
missing
element.
element. So the missing element would be
the
the entire grid. Actually, we could write it over here. This could be like a else block. It could be like a if block inside an if block. So it could be like if I, this is for the missing thing, right?
So
So you're gonna find the missing element. Okay, let's just do this.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve a problem, find missing and repeated values. So the idea is that we're given a square grid. It's an n by n grid. So it might look something like this. I guess I'll take the first simple example in this case, where the grid has 1, 3, 2, and 2. So the range of values in this grid are going to be limited to 1 through n squared. So in this case, n is 2, as you can see, like they tell us to return it place, default initialize any value that isn't already inserted in the hash map to have a count of 0. If you want to learn all those like tips and tricks in Python, after that is done, we want but then we just want to identify which
That is definitely not the answer, as we can see. Two pass and one pass. I need to learn what that word actually means. It's kind of getting two pass and one pass. Bro,
What
what the fuck?
How the
This is not an easy question, bro. Given a pattern, okay, let's try this again. So, given a pattern and a string S, find if S shows the same pattern. Here, follow means a full match such that there is a bijection between a letter in pattern and non-empty word in S. Specifically, each letter in pattern maps to exactly one unique word in S. Each unique word in S maps exactly to one letter in the pattern. No two letter maps to the same word and no two word maps to the same letter. Kind of a convoluted way to say AB, AB. So it's similar to a palindrome. Bijection can be established as maps dogs, maps to cat. So this maps to this maps to this maps to this. Okay. So I just have to like look into the first letter of the pattern. So I'm given. So let's just go to the code for S and I. Oh, it's a string. I'm pretty sure I could use like a Python, but I don't want to use it though. So I need to find the way to locate the first element after the space to biject the elements. I'm pretty sure that's like a Python. What does this do?
Yeah,
Yeah, it just splits out. That's actually okay. That's a nice little thing to like keep in mind. Split. That does that. So I just have to have that. And for I in S, if S index 0, comma, okay, X, S index I, let's sort it. Can we like sort this at the same time? No, I don't have to sort it. No, that's wrong. Is not equal to S? No. Is not equal to the pattern.
If it is
If it
not
is not equal to the
pattern,
pattern, we're just going to return false.
I think
I think that is it.
Okay,
Okay, that makes sense. It's got to be the zeroth element, not the first one. Bro, this is like retarded. Like, what is wrong with this? But the issue is it's the other way around. Why the oh nah still
doesn't
doesn't make any sense. Oh man. Bro, I don't want this. I don't want this. Respectfully though. Yeah, this is the most important thing. I think I'm done. Okay, I'll just write something about. Nah, it's already here. So I'll come back and try to do this. Yeah, this is the way to do it. I think I need to max out on all of these. Max out on all of these. Like completely understand all of these, and move on to the next one instead of like bunny hopping every single minute I get stuck. So let's look at the roadmap. So I need to max out on this, all the easies, and try to get the blind 75. I mean, I don't even need, do I need to do the blind 75? I think it's like too much. I need to max out this and work on the blind 75. Max out on the easies and blind 75. That's the goal.